Hello friends, myself Praveen Kajri. Welcome to the video classes. So in this class I am going to explain previously appeared net questions on operators. So let us take first question. So this is the question. The question is the commutator Ly and Lx has a value equal to. That question was asked in net 2010. Right, so there are 4 options. So we have to find out commutator of Ly and Lx operators. So in order to understand this question, we have to understand one generalization here. So that is, we have to find out the commutator of Lx and Ly operators. Right, so in order to do this, we must know the commutators Lx, Ly and Lz operators. Right, for that, so I have to use this determinant I, J, K, L is equals to x, y, z, px, py, pz. Right, so Lx equal to ypz minus zpy, ypz minus zpy. So Ly is equals to, so that is minus Ly is equals to, this is plus, this is minus, this is plus, that is equals to xpz minus zpx. Right, similarly Lz is equals to, operator Lz is equals to xpy minus ypx. So this is what we know from our basics of operators. Right, so here by making use of this we can solve this one. So this Lx and Ly commutator is equals to what? So that is equals to Lx is equals to ypz minus zpy. Right, so what is Ly? Minus Ly is known, so that is Ly is equals to zpx minus xpz. Right, so this one can be expanded by using the linearity property of commutators. Right, so that is equals to ypz minus zpy and zpx operator minus this minus I have to write here. So ypz minus zpy xpz. Right, so again by making use of linearity property of commutators, I can write this one as ypz, commutator of ypz with zpx minus this one zpy and zpx commutator. This minus commutator of ypz with xpz. This minus I have to write, but there is always already one minus, therefore I have to write plus zpy and xpz commutators. Right, so these commutators can be expanded by using a distributive property of commutators. Right, that is ypz and z commutator, it is multiplied to x operator plus z operator as it is commutator of ypz with px. This is one thing. Next, minus zpy, z commutator of zpy z px as it is minus this minus I have to write here, this one I have to write z into zpy and px commutator minus this minus ypz and x commutator and pz plus minus, I have to write this minus x into ypz and pz commutator plus this one zpy x pz commutator pz operator plus zpy I have to write x zpy and pz commutator. So this one is expanded by using a distributive property of commutators. So again this one is also a multiplication of two operators, right? So this one can also be expanded by using the distributive property of commutators, that is, so this is equals to yz into pz plus y into pz and z commutator. So whole thing is multiplied with what? Px, right? So plus z multiplied with, so again expand this by using distributive property. So commutator of ypx pz as it is plus y pz into px, right? So next thing is this one, this is over, next I have to expand this one plus minus commutator of z into z py plus z into the commutator of py and z, whole thing is multiplied with px, right? So next one minus z within the bracket, so z commutator of z and px multiplied with py plus z into commutator of py px. So this and this is over now. Now we have to expand one more thing, this one minus within a bracket commutator of y x multiplied with pz plus y into commutator of pz and x multiplied with pz, whole thing is multiplied with pz minus this one is over now, this one I have to expand minus x within a bracket commutator of ypz and pz plus y into commutator of pz and pz. So this one is over plus this one I have to expand. So within a bracket z commutator of z and x into px py, right, plus z into py and x commutator, whole thing is multiplied with pz. This one is over. So plus x within a bracket z into commutator of z and pz multiplied with py plus z into commutator of py and pz. So this thing is expanded like this. So in order to understand this one, we have to make use of the properties of commutators. That is, first property what we have to use is, every operator commute with itself. This property, this is what we have discussed already, right? So here every operator commute with itself, that one we have to make use. Second property what we have to make use is, two operators depending on different independent variables. Commute with each other. So we have to make use of these two properties of commutators. First one is, every operator commute with itself. What do you mean by that? Let us take x is an operator. Its commutator with the same operator is always equals to 0. This is what we know, right? That means every operator commute with itself. One point. Second point is, two operators depending on different independent variables. So x is the operator which depends on x variable, right? Similarly, y is one more operator which depends on y variable, right? So their commutator is always equals to 0. That means two operators depending on different independent variables, they commute with each other. That is what the meaning of this statement. So that means, if I take px and py, right? So px means what? This is nothing but h by I d by dx. Py means h by I d by dy, right? So that means px dependent on only x variable and py dependent on only y variable. That means these two operators depending on different independent variables, therefore these two commute with each other. So their commutator is equals to 0, right? By making use of these two properties of commutators, we can solve this one, right? Let us do it. So this is equals to yz, second property what I wrote here, right? So according to that, two different operators depending on different independent variables, right? They commute with each other. Therefore 0 into pz, that is 0, plus y as it is within a bracket pz, z we don't know about this, whole thing px plus z within a bracket. So y pz, this is dependent on one independent variable x, this is dependent on y variable. Therefore, so according to second property, so this becomes equals to 0 plus, so this here also, this is dependent on one variable, this is dependent on another variable. Therefore 0 minus z and z, every operator commute with itself. Therefore this becomes 0 plus, so again this becomes 0, pz px, right? Px minus z, so again 0 plus this one 0, right? Minus 0 whole thing becomes equals to 0, pz minus x into this is 0 plus y into every operator commute with itself, therefore 0, right? Plus within a bracket, so this becomes equals to 0 plus this one 0 into pz plus x into this one, I don't know the value of this one, z, commutator of z and pz into py plus, so this one dependent on different independent variables, therefore this becomes equal to 0, right. So this is equals to, within a bracket, y commutator of pz and z whole bracket multiplied with px. This is the only term that is left. Along with that, everything is 0. This one is non-zero value, that is x within a bracket commutator of z, pz and py, right. So this is what we left. So we know that commutator of x and px is equals to what? So this is equals to I h bar. This is proved in the last video. So therefore y into this one, so this one x into px commutator is equal to I h bar. If this is like this, px into x commutator, so this should be equals to minus I h bar. This is according to anti-symmetry property of commutators. So therefore this one is equals to minus I h bar. So here variable is x, here variable is z, that is the difference. So whole thing multiplied with px plus x into, so again this one I h bar into py, right. So this is equals to, so minus I h bar into ypx plus I h bar into xpy, right. Take I h bar common, so remaining thing is xpy minus ypx. So this is equals to I h bar within a bracket, this one, what is that, xpy into minus ypx. So that is nothing but lz, that is nothing but lz. So that means commutator of lx and ly operators is equals to what, I h bar into lz, right. You can remember this, it's very easy. So here similarly, if I write ly and lz operators commutator, so that is equals to I h bar into lx. So you can prove similar to this one, you can prove this one also, right. So this is one more generalization is lz and lx commutator is equals to I h bar into ly, right. So these three generalization you can memorize while solving the problems, right. So now let us solve this problem. So by making use of this generalizations, we can solve this problem. The commutator ly lx has a value equal to, so options are given. So for that we know the commutator of lx and ly, not ly and lx, right. So that is equals to I h bar and lz multiplied with lz, right. So in order to obtain this one, what we have to do, we have to invoke the anti-symmetry properties of commutators, that is ly lx is equals to, if you reverse the operator positions, then I have to multiply this one with minus 1 I h bar into lz. This is what I have to obtain. Match this answer with your options 0, not. So this one I lz, they have given only I lz, right. It should be I h bar lz. No, this one, this is not multiplied with lz. So this one, so that is also not matching with our answer. So they might have given the options wrong, or they have considered this one as neta, so as a constant, right? So this is equals to I minus neta into Lz. So this may be the answer for this question, because here neta they have considered as a constant for h bar. So this multiplication is nothing but a neta. So this one must be the answer for this question. So in this question you have to understand the solution for this commutator, that is commutator of Lx and Ly, that is equals to I h bar Lz. By the same sense we can generalize two more commutators, that is Ly and Lz commutators and Lz and Lx commutators, right? So let us solve one more problem. So here is the next question. If commutator AB is equals to 0 and AC is equals to 0, so what they have given is commutator A and B is equals to 0 and commutator of A and C is equals to 0. This is what they have given. Then which of the following necessarily holds? So out of these four options, which one is correct? Commutator of B, C is equal to 0, whether it is correct, or this one is correct, or this one is correct, or this one is correct. So they have given these two. By making use of these two, you have to prove that which one out of these four is correct option. So that is what we have to prove. So this question was asked in NET 2010 as well as in 2017 December, right? Let us solve it. So first option. So they have given that commutator of B and C is equals to 0. So is it possible to prove B, C operator, commutator of these two operators equal to 0 by making use of these two? No, it is nothing to do. This one is nothing to do with these two, right? So then option A is wrong. Option 1 is wrong. Let us take second one. Let us take, okay, second option. So what is that? Operator, commutator of operator B, A and BC, BC operators. So commutator of these two is equals to what? That is what we have to prove. So this is equals to, this one I can expand as, by making use of distributive property, operator A and B commutator is multiplied with C plus B as it is operator B commutator of A and C. So this is equals to commutator of AB is equals to 0, that is what they have given. That means this whole term is 0 plus commutator of AC is given, that is 0. This whole term is 0. So therefore this is equals to 0. So therefore this statement is, this equation is correct, right? So let us try to solve this one. Third option. So third option, what is that? Commutator of B and multiplication of these two operators AC is equals to what? So by making use of distributive property, I can write this one as B A commutator C plus A as it is commutator of BC. So this is equals to AB. So AB commutator equal to 0. This one becomes minus 0, right? Right, minus 0 means this one whole term becomes 0 plus A BC. I don't know the value for this one. They have not given commutator of BC. Therefore, so answer for this is A multiplied with commutator of B and C. So this is not equals to 0. Therefore, third option is also not correct option. So what about fourth option? So commutator of C, A and B multiplicative operators, multiplication of those two operators. So this is equals to commutator of C, A multiplied with B operator plus A operator multiplied with commutator of C and B operators. So this is equals to CA, what is that? Where is that? So this one. So that is 0, whole term becomes equal to 0, minus 0, that is nothing but 0. So next one is this one. We don't know the meaning of, we don't know the value of this one, this commutator A commutator of C and B operators. So this is not equals to 0. So they have given that this is equals to 0, but that value is not equals to 0. That is what we have proved. So therefore this option is also not correct option. So 1 is not right answer, 3rd is not right answer, 4th is also not correct given equation. Therefore the second one is the right option for this question. Hope it is clear. So here we have solved only 2 questions. Those are previously appeared net questions on operators. So in the next class we will solve some more net appeared questions on operators. So thanks for watching the video. Please share this video with the students in need. Thank you so much.